Okay, guys, we are in Advanced Math Trig Honors. It is Monday, April 6, 2020. We're ready to start our second week of remote learning or online learning, distance learning, whatever you want to call it. So far, you guys have done an awesome job. You're, I hope, watching the videos, learning the material. You're doing your assignments, you're sending me pictures, I'm keeping up, I hope, with your daily grades. And so far, so good. You guys have done a great job. Today, the topic is hyperbolas. So just as we've been doing, I suggest certainly, keeping a nice, well-organized notebook so that when the year does end, you've got something to carry forward into next year. Hyperbolas is the third of our conic sections that we're studying. As we've been doing here, I would go ahead and divide your paper into 4 parts. And we'll try to do one hyperbola in each block, and then on the back, and again with one that's not in standard form at all. And we've got a lot of work to do to get it into standard form. First of all, if you'll remember, we did do circles on Thursday. We did ellipses or oval shapes on Friday. And now we've got a conic section called hyperbolas. Now, what is a hyperbola? What does it look like? I gave a brief description when I did that initial overview of all the hyperbolas. We'll understand, I think, in a lot more detail what a hyperbola looks like and how it works once I do this first example. So here we go. Okay, first of all, if you look at this, compare maybe some similarities to things we've already done. I'm going to cover up the bottom number 4 and the bottom number 9 for a second. And we do see again a recurring theme here, x squared and a y squared. So just like a circle had an x squared and a y squared, and an ellipse had an x squared and a y squared, a hyperbola will also have an x squared and a y squared. The obvious difference between a hyperbola and the 2 sections that we've studied so far is the minus sign in the middle. The second that you see a minus sign in the middle of your x squared and your y squared, that is the giveaway that, this is a hyperbola instead of a circle or an ellipse. Now, just like an ellipse, notice this one, which yes is in standard form, does indeed equal 1. So all hyperbolas have x squareds and y squareds. They all have minuses in the middle. And to get it into correct standard form, you do want it to equal 1. Now, since this one's in standard form, we're ready to try graphing it right now. So I'm going to sketch a nice, normal-looking XY coordinate system. And just like on the last 2 things that we've done on Thursday and Friday, because it's plain old x squared and plain old y squared, and there's no numbers attached to those number values, like down below here when we've got the x plus 2 and the y minus 1, the center of this hyperbola is going to be at the origin, 0, 0. So I'm going to start with a dot on the origin, right? CR for center, and that's our beginning point, just like we did with circles and ellipses. Now I'm going to start out attacking this problem just as if there was a plus sign in the middle and it was one of our ellipses. Notice the x squared has a 9 under it. Well, of course, what number did we square to get 9? That would be 3. And since it's under the letter x, I'm going to go to the x-axis, and I'm going to go right 3, and I'm going to go left 3, and make 2 dots. And since the y squared has a 4 under it, I'm going to go up 2 and down 2. And if that would have been a plus sign in the middle and this was an ellipse, I, of course, would connect these up and make a nice oval-shaped ellipse like we did on Friday. However, this is something called a hyperbola. So when you graph this, here's what you got to do. First of all, step number 1, once these dots are in place, you've got to make 4 corners of what's going to look like a rectangle. So I'm going to start on this dot, kind of follow up until I get to that dot and make a corner. Go to this same dot, go down below, and make a corner there. Come over to the other dot and make a corner up to the top left, and come down to this level and make a dot in the bottom left corner. Oh, so looks like if you look at the 4 dots I just created, I've got a rectangle sitting here on my paper, and you use the dots that I created to draw an imaginary line diagonally through the center, and another imaginary line I'm going to draw diagonally through the center. Those are called our 2 asymptotes. Asymptotes in math, of course, are imaginary lines that you can't see, but they are used to guide how wide you're going to create your picture. Now, to finish drawing this picture, notice if I use the 2 dots on the x-axis, I could draw a curve pointing to the right, and I could draw a curve pointing to the left. If instead I used the dots on the y-axis, I could draw a really wide curve pointing up and another wide curve, in this case, pointing down. How do you know which picture to draw? That is determined by the letter that comes first. So if the x squared is the letter that is written first in your equation, it opens left and right along the x-axis. So all I'm going to do is start on the x-axis, take this dot, draw a curve that's going to get close to that asymptote, and a curve that get close in this direction, and then go to the other dot on the x-axis and draw a curve that gets close up above, close down below, and I end up with what looks like, let's just say, a satellite dish facing east and a satellite dish facing west. And that completed picture that you're looking at is called a hyperbola. Okay? All right, let's roll from there. Go to block 2. Notice it says 4y squared minus 9x squared equals 36. The first thing I notice is the minus sign telling me, oh, that's a hyperbola. However, it's not equal to 1, which we've already said all hyperbolas need to be when they're in standard form. So it's pretty obvious here we're going to divide by 36 on both sides. Now over here I got a 4 over a 36 and then a 9 over a 36. So cross-canceling and reducing that scenario, you should have y squared over 9 minus x squared over, what is that, 4 equals 1. And I got that one into standard form. Looks very similar to the one we just did. So real quick, when I go to draw my coordinate system, notice it's plain old x squared, plain old y squared. So again, we'll start with the dot on the origin as our center. Notice the y squared has a 9 under it this time. So I'm going to go up 3, down 3. The x squared has a 4 under it. So I'm going to go right 2, left 2. And once again, instead of connecting and making an elliptical shape, I'm going to go up and make a corner, down and make a corner, up and make a corner, down and make a corner. Those corners are used for the 2 asymptotes that are important imaginary lines because they're going to guide how wide I'm about to draw my picture. Notice this time the y squared is the first letter. And I just said whichever letter is first will determine which directions to draw your picture. So since the y squared is first, I'm going to draw my hyperbola opening up and down along the y-axis. So it's going to go up and down. And notice the asymptote is there to guide how wide you should make your picture. Your curve should get really, really close to each dotted line, but never cross over or touch. Okay? Look at block 3. X plus 2 squared over 6 minus y 1 squared over 12 equals 1. There's a minus in the middle, tells me it's a hyperbola. It's equal to 1, tells me it's in standard form. The x squared and the y squared, however, have numbers attached to them. So that's telling me that the center is no longer 0, 0. Now remember from last week, you always take the opposite of the sign that you see. So since that's x plus 2, the opposite, of course, would be negative 2. And since that says y minus 1, the opposite would be positive 1. So negative 2 comma 1 is the center of my hyperbola. So I'm actually going to go left 2, up 1. There's my center. Now the x, or the x squared in this case, has a 6 under it. Guys, careful. It doesn't mean go right 6 and left 6. It doesn't mean go right 3 and left 3. You don't cut that number in half. Remember, the rule is to square root that number. The square root of 6, if you get your calculator out and do it, should be 2.4. So I'm actually going to go right 2.4, left 2.4. The y squared has a 12 under it. I use my calculator. I figure out the square root of 12, and it's 3.5. So I'm going to go up 3.5, down 3.5. And those dots, again, allow me to draw a corner, a corner, a corner, and a corner. An asymptote, and an asymptote. And notice those asymptotes always go through the center of my hyperbola, not through the origin. And because the x comes first, it opens left and right along the x-axis. Notice this time how wide these satellite dishes are going to be compared to the width of that first one, because the asymptotes are further apart. Okay? Finally, look at the last one on the front, our last basic one we're going to attack. I do see the minus. It is a hyperbola. However, there's a 20 at the end. So, again, reiterating, I'm going to divide by 20 because all ellipses and hyperbolas are in standard form when they're set equal to 1. So this ends up being y minus 2 squared over 20 minus x squared over what? 4 equals 1. It's in standard form. Now careful, a lot of kids, when they go to graph this one, they think the center is 2, 0. Guys, here's the x squared, and over there is the y squared. The center, of course, the ordered pair is always x, y. So my center is actually going to be 0, 2. Agreed? 0, 2 is my center. So I'm going to go right 0, up 2. There's my center. The y squared has a 20 under it. The square root of 20 is 4.5. So I'm going to go down 4.5 and up 1, 2, 3, 4.5. So I'm getting real close to the problem there. The x squared has a 4 under it, so big deal. From the center, I'm going to go right 2 and left 2. Put a corner, a corner, a corner, and a corner, an asymptote, and an asymptote. And based on this picture, because the y squared is first, it's going to open up and down along the y-axis. So I have a hyperbola, rather narrow, pointing down, and another hyperbola that ends up pointing up. Okay? All right, any questions on that? If you need to go back and review the lesson or just look at one particular problem, if you get stuck somewhere on your assignment, that'd be fine. Last thing, flip that over to the back. The last problem we're going to do together is one that requires a little bit of work. It says 9x squared minus y squared minus 36x minus 6y plus 18 equals 0. This is the type you might see on a college entrance exam, an ACT test. Next year in calculus, when you sketch and graph pictures that are conic sections and not necessarily functions, and you got to find slopes and areas and volumes of three-dimensional shapes, etc. If you are asked to graph this picture and then find the slope at a particular spot, you can't do that if you don't remember how to get this big mess into standard form. So let's give it a shot. First of all, it is important to note the 4 problems we just did on the front. Remember, the minus sign was always in the middle. So whichever letter is positive is going to be written first when I put these families in the correct order. So looking at this one, I'm going to go 9x squared minus 36x. Notice that's part of his family. They're grouped together. Leave a blank space. Then, because the y squared has a minus in front of it, I'm going to put minus y squared. That family's going to go second. Minus 6y and a blank space equals, and just like Thursday and Friday, that constant 18 doesn't have an x, doesn't have a y. It doesn't belong with either family. It gets subtracted over, and I write minus 18. Okay, normally when we complete the square, we cut the middle number in half and then square that answer. Remember, you cannot complete the square unless it's just x squared. The x squared is not allowed to have a coefficient in front of it for that process to work. So it's pretty obvious in this first family, you're going to factor out a GCF of 9. Wouldn't that leave you with x squared minus 4x and then the blank space? And notice, because of the minus sign, again, we want that to just be y squared when we complete the square. So we got to factor out a minus 1, leaving me with y squared plus 6y and a blank space. Because remember, when you factor out a negative 1, it changes the signs of the numbers that originally were there. Still equals negative 18 on the right side. Okay, now I can complete the square. If I cut negative 4 in half, remember I get negative 2. Negative 2 squared gives me plus 4. And whatever I do to one side, I got to do to the other. So you're awful tempted to write plus 4. But remember, that 4 that you wrote had a dot-connected 9 in front. So if this was a scale, you really just added 36 pounds to the left side, so you got to add 36 pounds to the right side. Cut 6 in half, you get what? 3. 3 squared gives you plus 9. Once again, you're tempted to write plus 9 on the other side, but that plus 9 has a negative 1 dot connected in front of it. So if I have a negative 1, dot connected to a 9, that's really negative 9, and whatever I do to one side, I got to do to the other. So I put a minus 9 on the right. So you do got to focus and be careful. Over here now, that gives me a 9 in front. This trinomial, this perfect square trinomial, will turn into what? X minus 2 squared, because minus 2 is the answer we got when we cut the middle number in half. Minus 1 times, and then that would be what? Y plus 3 squared equals, and if I add up the 3 numbers on the right side, negative 18 plus 36 is 18 minus 9 gives me 9. There's a minus in the middle, but it's not equal to 1. So if my goal is to just get this into standard form, I need to finish this problem by dividing by 9. Giving me a final answer of, now notice that 9 and that 9 will cancel, and then here I've got a 1 and a 9. So bottom line is, I end up with x minus 2 squared over 1, that's okay, minus y plus 3 squared over what? 9 equals 1. And I successfully took what looked like a big mess and turned it into a hyperbola in standard form that I could now graph if I have to by using the approach that we learned on the front. Okay? Homework. Your first assignment of the new week. As always, today again is Monday, April 6th. So these 4 problems are due tomorrow, Tuesday, April 7th at 12 o'clock at noon. So whatever time you're doing this, you've got all day today, all night tonight, tomorrow morning if need be, but certainly to ask you to try 4 problems. The first 3 you will graph and draw as perfect a picture as you can. The 4th one you will just get into standard form like the one I just did. Notice the y squared is positive, the x squared is negative. So the y squared will be your first family and the x's will be your second family when you attack this problem. So there they are. Hit pause if you have to so you can copy them down. But those are your 4 homework problems. Again, the first 3 work out on your own. Give me a picture or a graph of each one. And the last one should end up into standard form. All right, thanks guys.